Hello, welcome back to the Instech podcast. Zoya, podcast producer here. This week on the podcast, we have Sarah Russell from Bellwether, part of Google X. Sarah spoke earlier at our Exponential Risk conference, and we actually met her last year at our New York event. Instech is returning to New York this year, and we brought back Sarah to speak more on wildfires on the podcast. So, Matthew, what key insights do you want our listener to take away from this week's episode?
There's so much in this one, Zoya. I think one thing people often wonder about is Google. You mentioned Google X. So Bellwether is part of Google still, has got access to so much information. What are they doing with it? How are they using it? And then the other one is when people think about using analytics to look at underwriting or make underwriting decisions, the temptation is to find the areas that people shouldn't underwrite. But of course, they can also be used to find areas that people might be overestimating the risk from. And therefore, ultimately, everybody wins because people that are looking to get insurance protection can find organizations and analytics that actually identify where they've taken mitigation measures. We talk a bit about what those are for wildfire, and can be offered insurance that reflects what they've done. So I think it's a really intriguing angle for that. And then we talk a little bit about what else is going to be happening. Sarah gives her predictions for the year ahead, which I am going to hold her accountable for. So we'll come back in a year's time to see if she was right.
Yeah, no, those were quite poignant. What I found really interesting is why Sarah mentioned that wildfires fit an AI model better than the physics-based model. And for any of those listeners who aren't familiar with the term yak shave, then carry on listening to find out, because it's quite an interesting concept. Over to Matthew and Sarah.
Sarah, it's great for you to be joining us. Thank you for getting up some horrible time early in the morning. I know you California is like an early start, but it's quite early in the morning. But we had the chance to see each other last week. Delighted to be talking to you on the podcast. So welcome.
Thank you for having me. I feel like in adulthood, you can't complain about 7:15 anymore. Although my voice is still a little rough, excuse me. Maybe there's still people who are night owls and work all night long and then wake up at 9. But I'm so happy to be here. So thank you.
It's great. And you get the benefit of knocking off earlier in California. So there's a lot of things we could cover. We had the pleasure of seeing you a couple of weeks ago at our Exponential Risk event. I very much enjoyed interviewing you on stage at Google offices, which is kind of your parent or Alphabet, last year. So we're going to cover a few things. But first of all, what do you want to talk about? What's top of your mind just now? And then we can organize this discussion around that.
Let's talk about wildfire because it's still important. It's still meaningful. I think we have a great product in the market and it's a great conversation. And also, let's talk about the future and what these large models mean. I think that's fun.
Well, I think the future will include artificial intelligence, generative AI, maybe even agentic AI. So you were a spin-off from Google X, owned by Alphabet. You yourself have got a background as an entrepreneur. You actually are a trained physician. But just to set the context, it'd be just great to get a quick view as to where Bellwether's come from and what's the key problem you're trying to solve for insurers. You gave the hint there with wildfire, but just a bit more on that would be great.
So to be clear, we actually haven't yet spun off from X. We're still a part of the mothership. We're sort of in the satellite office, still one of the pods attached. And this is the mission of X, is to start groups that we call moonshots, or get after problems that are huge problems that require breakthrough technology, usually using a radical solution. This is sort of the features of a X moonshot per se. And the moonshot of Bellwether is in fact to build a prediction engine for the Earth and everything on it. So the idea of a voxel-based 3D view of the world with prediction capability. Now that is entirely a moonshot, right? So one of the biggest questions and sort of challenges and frustrations is, well, where do you start if you decide that you want free energy for all, for example, or free internet for all? Where would you start? What's the first thing you would build? And for me, when it comes to understanding the Earth and everything on it, the first thing you might work on is understanding or working on a problem of the way in which the world is changing now that is causing pain or loss or difficulty or causing a problem for somebody. It's certainly the case that climate change here and now is a real problem, and it's a real problem for insurers. But insurers don't call it climate change per se. They call it severe weather and natural catastrophes, all of which are getting worse in the face of climate change. So then once we decided that the insurance industry or the risk transfer industry that was in the business of matching capital to risk or pricing risk, they are really the most relevant and the tip of the spear when it comes to understanding the changing earth. And for that reason, we spoke and talked to them first. And the risk transfer industry said, the hardest problem for us is wildfire when it comes to severe weather. And so that is why we started with wildfire, and that's where we built in that space. And to be clear, it's so hard to build a company. It's so hard to get going as a startup. You have to sort of ask yourself, well, why would I have a right to win? Where would I be somewhat have a head start? And for us in the Google ecosystem, we have a head start when it comes to geospatial data. So information about the Earth and Earth observation data, everything that powers Google Maps is in our wheelhouse. And so that was a good place for us to think about leveraging those resources when we were going after a problem like wildfire.
Wow, a lot in there. So let me just review that a little bit. But I like the way you set the context. So prediction engine for the world, then you kind of narrow that down to look at climate variability, climate change, different time dimensions. But have you look at it, severe weather risks, severe man-made risks, narrow that down further. You build on the assets that your parent Google has, tighten up the focus a little bit. And one of the biggest unknowns, and as we all know, that one of the biggest losses, certainly this year so far in the US, is wildfire. So that's a really sort of clarifying way of thinking like big problem, but solve it through the lens of wildfire. Have I sort of play that back to you correctly?
I mean, brilliant. I mean, I gave you the origin story, but today, so the big picture is prediction engine for the Earth. But today, Bellwether uses absolute risk scores and real-time data analytics to provide better insights, data, actionable information to communities, businesses in the face of natural disasters. So the idea is, can we power people to take action? And we do that through absolute risk scores and real-time data analytics.
You mentioned before, which is your kind of somewhere in that arrow or focus, was the insurance element, which you sort of alluded to again there, which is incredibly important because, I mean, I sort of slightly see this through my lens of being in the insurance world forever, but it feels like to me insurers have a better understanding of, you connect the person that's suffering the risk to the people that have got the capabilities, the advice, the money to solve it. And actually, if you're going to have a prediction engine that actually not only predicts, but helps people solve their issues, that's one of the great ways to do it because you're joining up all the dots. So it makes complete sense the way you described it to set up a company that's focused around wildfire. And let's talk a little bit about wildfires. We had big wildfires this year in the Palisades. There's been wildfires the last 2 or 3 years. My history of working in this world of catastrophes, wildfires have gone from like nobody really noticing them to be now up there, as big as worrisome as hurricanes and earthquakes. But it's more specifically, can you talk a little bit about why you chose wildfires? You could have chosen flood, you could have chosen severe convective storms, tornadoes. They're all very top of mind for people. So why wildfires?
Wildfires in our own backyard, right? We're in California. That's one reason. Another reason is it's urgent and growing. There's evidence that it's getting worse, and it's getting worse at a sort of slope that makes it compelling from a business perspective, right? Going after a growing problem. And also, I would argue that there are lots of good folks doing work, at least at the time when we started. Flood was being taken on by very good companies, but we didn't think that there were a whole lot of players in the wildfire space. So that's another reason to get into it, right? Is we thought it's not intensely competitive with really strong competition. Again, this was years ago, but now I would argue one of the main reasons is wildfire is an intensely data-heavy project with dynamic data. Trees grow, they die, seasonal changes of the earth, the vegetation changes, rains come, it grows, it gets dry, they become vulnerable to burn. All of those cycles occur in the space of a single year, which means wildfire risk is changing all the time, which means your ability to suck in new data, manage that data, understand and have the model learn from all those changes is just a heavy load and a big challenge. And we were advantaged because of our role sort of as computer scientists and as software engineers who understood how to work with big data systems, parallelize and so forth. But we also had access to the cloud and the ability to store and work with these huge data problems. But I mean, in some ways, wildfire is a great fit for a sort of AI first approach because a physics-based approach was clearly breaking and not working. So that's sort of maybe reason number 4. I forgot. I lost track what reason I'm on. But another good reason to get after wildfire is it's such a good fit for AI. And if technology is changing and we're moving away from purely physics-based approaches, it's nice to work on a problem where AI is a great fit. because AI is really good with big data. It's really good with smoothing out sort of challenges where there isn't perfect data. It can smooth through those sort of errors, whereas a physics-based model just breaks entirely. And then finally, AI can now anticipate things it's never seen before, or imagine fires that's never seen before, like fires ripping through the Pacific Palisades. An AI model can imagine that or predict that or forecast that in a way that a physics-based model can't. So these are all other good reasons to go after wildfire with our AI-based approach.
And let me just, for the purposes of people that might be want some clarification around that physics-based approach and tapping into my early career as an engineer, I mean, a physics-based approach essentially is when you're constructing the model based on physical parameters. You rely a lot on experience, or at least trying to deduce the experience. And the reason it falls down is because you've got the complexity of wildfire. And I would say there's still lots of gaps of information, both about what you can see using traditional methods, literally see in terms of like what properties you're looking at, what the construction type is. But if I characterize that correctly, and the way you're distinguishing what you can do, as you said, with the power of the Google Cloud behind you for an AI approach versus the more traditional modeling approach of a physics-based approach.
And you nailed the physics-based approach. That's exactly it. It's sort of heavily parameterized, but think about it as something that is sort of committed to and locked into a process. And you have to do step A, step B, step C, step D, step E. And if you have a problem with step D, you got to start all over again, right? Machine learning can say, well, actually, I know something that looks a little like step D. I'm going to fill that in. Step D is, I'll find it an alternative. Or maybe I don't need step D, right? Machine learning, and sometimes it does that in very clear, explainable ways, which is what we try to focus on. And sometimes AI does it in a black box way, which makes people anxious. What do you mean you don't need step D? And then people are like, it's doing astrology. It can't be real. This is like, it's panic inducing because we've come up understanding step D in great detail. So our bridge through that is by actually asking the model, why did you skip step D? And to give up on that metaphor, it's also like saying, why did you call this home that's near a golf course? High risk. Everyone knows golf courses don't burn. Then it says, well, no, actually, there's a ton of very dry vegetation on this golf course. And with ember spread, this home is more likely to burn. So you can ask the model something about a counterintuitive result it gave. This is what you can do with an AI-based approach designed a certain way versus a physics-based approach where you can never really get to a situation where physics would ever allow you to have a home near a golf course burning. Does that make sense?
It makes complete sense. And actually, it touches into something I was doing over the weekend, just pushing the sort of my boundaries of knowledge for ChatGPT, probably well below what you're doing. But taking various different white papers, PDFs, putting them into one of the ChatGPT research engines, or maybe Gemini is an alternative choice as you're from Google, and actually just asking it to tell me, what is happening in the science of wildfire. So to your point, you can tap into the latest knowledge. The engine itself is learning, and it's telling you, hey, you got a golf course. I've learned that the golf courses have vegetation. I think that's what you're alluding to, isn't it? I mean, the tool is learning from lots of different sources, research, experience, in a way that otherwise you'd be relying on your individual PhDs and researchers to do not in isolation, but they have to have a lot of time to go and do that research.
In our partnership with the U.S. Forest Service, to give you an example, there was a car fire about 2 years ago in which we predicted that the burn risk remained very high in an area that had burned the year before. And the U.S. Forest Service is a partner of ours, a guy by the name of Bob Baird, was on site at the time. And he said, we were very surprised that you said that this would burn. This was at a high risk because it just burned last year. Why would it burn again this year? And sure enough, during the car fire, it burned right through and reburned. And Bob said this is a new paradigm. The idea that things that burned the year before will burn again. That's the other thing that machine learning can do, is kind of blow up these heuristics we have around, well, if it burned, the risk must have dropped. And the answer is sometimes the risk stays high because you have just enough vegetation. And by the way, this is why this advantage of partnerships with folks like the U.S. Forest Service is they can also kind of help us understand when the model comes up with something crazy, because they're still experts. So this is probably another important point, which is there's no AI in a vacuum. It's not just a bunch of Googlers in AI. We have Bob Baird, we have Karen McKinnon, we have all sorts of, she's at UCLA and works on heat waves, but these folks who have deep understanding of statistics or the nature of wildfire, they inform and they can kind of push on things and say the model's getting this wrong, So that's the other piece I should make very clear. We still rely on experts. You still need these people at the table. AI is allowing you to do things at scale, at faster, more accurately.
Yeah, well, we might come back and talk about that because we've got some sort of analogy, I think, with self-driving cars. But I just wanted to ask you also a question, Sarah, about how people are using your tools. One of the errors I see people make when they're building analytics is they want to go into an insurance company and go, hey, let me tell you all the things you don't know about all the problems you've got, and then I'm telling you how I'm going to fix it. And the reality is underwriters want to underwrite. And I think what's really intriguing about looking at some of what's happening now, and I think wildfire is one area we're seeing quite a lot of this, is particularly the challenges you've got in California with so many companies withdrawing and all the other things we're seeing coming out of Palisades, is the opportunity to go, well, actually, some risks are actually lower than you might think they are. And so here's an opportunity to come in and offer a service because not everything is equal, and start talking about mitigation. Is that sort of where you see that? I mean, clearly there's a role, and it's a very important role to help insurers understand the risk and mitigate it, transfer it through reinsurance, price correctly, of course, with the regulator review in the US. But there's also that side, which is an opportunistic one in a very positive way. Is that what you're seeing in terms of when you talk to people?
Well, absolutely. But here's the thing. I do think in the aftermath of Pacific Palisades, people were very excited to talk about the fact that they called all these areas high risk. And I would say it's not that hard to call things high risk when they burn, because you can go back and look and say, oh, I called them all high risk. Look, they all burned. It's far more challenging, but also important to say, look, I called all of these areas low risk and they didn't burn. Look at all these pockets I said were very low risk and they didn't burn. That is what drives a very high, what we call AUC score in machine learning, predicting low risk and high risk at the same time, being very good at discerning that. And the reason that's interesting for an underwriting team that's imagining taking on new technology is it represents the ability to do more of what they want to do, which is underwrite and sell policies and generate business. That, I think, is the opportunity with a model like ours, which is it's very good at discerning that risk. So people have an opportunity to actually use a model to write more wildfire risk, especially if there's intense regulatory pressure, or you can't have as much pricing flexibility as you want, or you're trying to construct a portfolio, right? Now, it's still just a risk score. It's not, there's all sorts of other tools we're offering now, including more of a portfolio or risk accumulation picture. But I still think the idea of showing folks that, at the lowest end, there's opportunity is another kind of fresh take on the problem. And we're particularly good at that.
I've got to ask you now, so what would the characteristics be of a low wildfire risk property or location?
I would say most commonly when something is low risk, that's surprisingly low risk, it's because of a few common features. One is the vegetation is of a type that's either particularly biodiverse, like, for example, if you have a big stand of Douglas fir or eucalyptus and they're all the same, it's very high risk. But if you throw in a few redwoods and a few different kinds of trees, that area just doesn't burn. It's kind of incredible, like a big stand of redwoods in the middle of other vegetation. It just burns a lot less because redwoods are highly burn resistant. And so it's just cool, like some of these vegetation types. So also distance from the vegetation. So if you're far away from that big public park or big public lands, and then proximity to, terrain of course. So if you're at the top of a hill versus a flat hill versus distance from a hill, terrain matters. And then weather is a big deal. Are you in the path of a big windstorm? Are you in an area that is in a heat island of sorts where things are more likely to have flash drought, that kind of thing? But the big factors are the common factors, which is, vegetation, weather, terrain. I would also say proximity. I mean, this seems crazy, but it is the case that there are places in Tahoe, for example, that we found to be particularly low risk. And it does seem to be like proximity to a big fire station or big water resources also, or just your ability to have a couple roads in and out of that area makes fire suppression more easy. And so the idea of a total loss is less likely.
I've got this wonderful image of somebody's house with all these wonderful redwoods, sort of like guardians, because they're so large. I guess the challenge is if you say to somebody, plant some redwoods now to defend your property, you're going to have to wait 100 years before they can. Guardians.
And you know what? And they don't really match the ecosystem of Pacific Palisades. Can you imagine these people like in Malibu just planting? I mean, it's ridiculous. Yeah. My point is more though that I'm just starting to come around to understanding how powerful biodiversity is, and this is like reason number 500 is biodiverse environments are less likely to have catastrophic burns.
Great. Well, look, I'm going to come on to the future in a minute, but just before we move on from wildfire, what would be your advice to somebody that's looking to acquire or test out a wildfire model, what should they look for? And you've given a few hints of this already, but what should they look for in terms of when they make their choice of comparing wildfire models?
One, how many data layers, how powerful is the data layer, how fast is the model updating, how frequently is the data refreshed? So we have 600 data layers. We retrain the model every quarter. And when we retrain, we get insights from all the past seasonal changes. We run it at 100 meters. Resolution matters. I don't think it needs to be at 2 centimeters, but I think it's better than a kilometer for sure. And also, I think being able to, so that's one piece, is just the quality of the model, which is a bit important feature. Then number 2, look at the historical accuracy of the model. Do some back testing or look at the results compared to other models, other forecasts, and look at that accuracy historically. And then number 3 is ease of testing and use and onboarding. I think we've learned quite a bit about the importance of just getting the tool in the hands of folks rather than trying to figure out a huge commercial deal at the outset, which is probably a mistake I made among many. But now I'm realizing the importance of giving people a chance to really work with the model for a year in their systems and to understand what's happening with their loss ratio. Because in a very simple demo or test set of data, you get one picture of what the results might look like. But I think the real value emerges when you start seeing all this opportunity. So I would say then the ability to, for a reasonable price, test the model and get it in your system for a year is another nice feature. There's something to look for. There's just a lot of goodness in really understanding the model against your whole portfolio as opposed to a small chunk.
I think that last point is really important. The tension between the proof of concept, people might want it for free. The reality is most insurance companies have got to go through a nightmare IT procurement validation process before they plug anything in. So why not just spend a bit of money? Sounds like you're kind of reflecting the fact they're testing it, but run it for a year because that's the only way you're going to know. So I think the takeaway from that is if anybody wants to run a wildfire model for a year, you're going to pay some money, but speak to Sarah and your team to figure out what you can do for them. I mean, that's my plug for you. So the future, loads of things going on. What is it about 2025, 2026 that is the most interesting from you? And my test case for this, people, is if we were to come back, well, hopefully we'll come back in a year's time and say, okay, we talked about something a year ago. How do we demonstrate that what we're enthusiastic about and predicting has actually happened? So great to hear what your thoughts are, but also to really ground truth it in actually what are we actually going to see that's different in 12 months' time, or you can maybe make it 2 years' time.
So I'm trying to think about how could we prove that we've learned something. So your question is, if in 1 year we look back, how will we know that we were right about what to focus on in 2025?
Or just in some cases, if you're using generative AI for efficiency purposes. Just a very trivial example, we're glad to know it was a Google Sheet. I had a Google Sheet, had all the information in one column. I wanted to turn it into lots of columns, stuck it in a chat GPT. 2 seconds later, it gave me it all formatted nicely and it was columns. I mean, it's trivial, but actually fantastic use case, demonstrably true. So it's that kind of thing. It's like, yes, not just only is something doable, but actually you can put a cost benefit or an opportunity against it. So it actually wasn't just doable, but it was meaningful.
Well, by the way, I love that example. I think if we all start collecting things, I mean, do you know what I did the other day? I was in a condo at vacation with my family, and there were about 4 condiments in the cupboard. And I said to ChatGPT, please make me a salad dressing. This is what I have. And it was delicious. These are these use cases you collect, and you're like, oh, this is fun. Okay, but back to reality. So here's what I think. We talked about this before. I talked about it on stage, and I think it is, it can be very confusing. So if we back up and we say, I'm about to talk about sort of the big changes and trajectories with respect to these large models. So backing up, AI, big overarching concept, artificial intelligence. The vast majority of AI that we talk about in tech and in our world is a version called machine learning, which is, this algorithm-based understanding of the machines learning a system and so forth, and then making forecast predictions to generating results. One version of machine learning is these large models. So the large models are, and that's the thing that we imagine to be transformative, like a true inflection point, like as big as the internet, this kind of thing. Our model, to be very clear, on wildfire and others are squarely in the other kind of machine learning space, which is machine learning from 2018, 2019, 2022, 23, right? These are all these methods that we used before. These new methods of large language models are truly powerful to a degree we haven't imagined, and are using kind of sort of insights from transformers generated a few years ago to do things at a parallelization that's just insane, right? So this new generation of models is not what we're using, but what I think the future is. So some of the things these new models can do are very cool spreadsheet simplifications. They can make a salad dressing. But I would argue the other thing they can do is potentially change our relationship to our data in and of itself. So that, or change potentially the way we think about our tech stack. So rather than think about our tech stack as something that is an endless yak shave of tech debt in which we constantly need to compensate and make up for it or buy systems that integrate, I imagine that in 5 years, we will have a totally different relationship with the proprietary data and all the data that's been accumulated in an insurance system. And it'll all be facilitated by a model that has an understanding of those systems and that content and the data in those systems and can make sense of it. It's because the pace of this technology is moving so quickly, and the rush for people to find applications in the real world is moving so quickly. I think we're going to land on something, and before we know it, it's going to spread, and it's going to be very exciting. But you asked for 1 year from now. And I would say 1 year from now, I think it's very likely that we will be using agents to clean and manage big chunks of data within, say, let's say it won't be across all of the product lines, but say just within commercial or something like that. Less regulated environment, say. I bet we will have these LLM-like tools, what we call agents, but agents is sort of poorly defined these days, but a toolkit that will allow us to work with our data in a way that's faster, cheaper, more efficient, and then connect it to all sorts of other publicly available and highly valuable data in ways that enrich our data, augment the data, and make it far more useful at a fraction of the price. I think that'll happen probably in one single product line, maybe not across the entire business, but a single product line and application. So what am I saying there? I'm saying faster, cleaner, more augmented, more accurate, higher quality data available at your fingertips for very little money. Very little money. I think the years of spending millions of dollars on proprietary data, I think that's going away. We're still going to need the insights of a wildfire model for sure. But it's going to be far more powerful to be able to work with our internal data systems and publicly available data.
Yeah, that's going to be a big shift for a number of companies that have built. Well, we're delighted. I want to come back to your tech debt. And I think what you said is a yak shave. Tech debt, just for those that aren't familiar, is basically where people underinvest in technology and incrementally you can get away with not upgrading or using a new system year on year, but suddenly you've got this massive debt. Effectively, you've got this massive debt, which means everything's slower. Just a mess, basically. Did I hear you right, Sarah? A yak shave. What's a yak shave?
Yeah, yak shave is like one of the world's greatest expressions. May we all use it. But okay, so first things first, tech debt is present in every technology organization. My team has tech debt. Sometimes we have to stop what we're doing and work on tech debt. And tech debt is everything from like testing, fixing bugs, making things work. But one motherlode example of tech debt is having half your stuff on premises in a server in the basement and half your stuff in the cloud. I mean, that's an example of colossal tech debt, which is how do we make this transition? We all have it. We all have it. But the extent to which we spend money trying to fix it and worry about it, I think will shift as we figure out other solutions. But that's tech debt, is just the idea that we have all these tasks that are important, but maybe not as urgent as others, and then we leave them, and then they pile up.
I think I'm getting the yak shave thing. So is this the idea like a yak is a big, very, very hairy, what is it? I'm not quite sure. A goat, a cow. And it's just like a monster to shave it. Is that where the word yak shave comes from?
I don't know where it comes from, but it's so fun to say and it's so evocative that you just say it. So who knows what it means? But here's the idea. The idea of a yak shave is like the endless exercise. I mean, I could tell you like 5 years ago when we first tried pulling together geospatial data to make a wildfire pipeline, you'd pull in a data layer and then you'd realize that it was at the wrong resolution, and then you'd have to correct the resolution and reproject it and then fix this polygon, and then you'd put it in and you'd match it to the other one, and then that one would break. You have to go back and correct that one, and then it would break, or, then you'd go back and clean the data again, and you'd spend all this time organizing, painstaking. I mean, that's a yak shave. The yak shave is like the endless problem solving, creating another problem. And sometimes it gets even bigger. Before you know it, you're just solving one problem after another. And the reason it's a yak shave, I would say, is in and of themselves, each one isn't backbreaking. It's just enough to crush your soul. So every single step you're taking in this exercise is exhausting you, is making you want to give up, is painful. And there are tasks like this all over but yak shaves eventually, you only just remember it in the past. You never want to do it again. I think the dream is to figure out the stuff that's a yak shave in these systems. And as an entrepreneur, say, oh, look, I have a faster, cheaper solution for you. That's the dream. And then let's run it across your organization.
Yeah, no, there's so many ways you could go that, but I'm going to move on from the yak shave now. I want to come back to the agents though. So your former colleague, good supporter for us, Nigel Walsh, and I were talking, 17th of March, I think. But it was very interesting because you mentioned that you gave an exact point there about agentic AI and agents, and Nigel and I are trying to figure out what was an example of that. Because I think, again, a little bit like we talked at the beginning there, the more people can sort of understand and use in their daily life these ideas, and the better you understand the concepts. And so actually, what I've come across in the last week as a good example of agents is, and I'm afraid I'm going to go to ChatGPT on this one, Sarah, rather than Gemini, is how now with ChatGPT, I think it's the paid function, you can invoke the kind of search chat or the research ChatGPT, and it's fascinating because in real time you'll frame a problem like, go and tell me about wildfire in California, and it will actually actively, first of all, ask you some questions to sort of really understand what you want, and then you'll see it going after all the sources. So these little agents are going out, and one's going to go and read that document, one's going to go to the library, one's going to go somewhere else. They'll whir away, and then 10 minutes later you'll get a incredible summary of all that's been put together. So I always think it's helpful because when you've got this new concept, agents, what is it really doing? That I know it's a simplistic example, but back to your point about the data, the equivalent with data is your agents are going out and they're looking at all sorts of sources, the publicly available sources, maybe commissioning. Hey, who knows? At some point you might even commission a satellite. Go and look at Sarah Russell's house because satellite imagery is so cheap. I want that data. So I don't know if that works for you, but I would quite like to bring these things back into applications that people can sort of understand and even try out in their own life.
It is useful. Now, the thing that's being talked about mostly right now is no one agrees on what exactly an agent is or how to define an agent. So it's important that's how early we are right now. There's no solid definition of what an agent is. But I like the way you're describing it, which is somehow an agent is a tool that can go and make decisions for you independent of your intervention and come back with an answer. So it has some autonomy or some ability to make decisions or decide good quality or poor quality or yes or no to an input and then come back with an answer. So that independent autonomy quality is sort of a feature of an agent.
So let's talk about that because that's inherent in what you were saying before about your example for data. And I like to use the example of self-driving car here, which is if somebody's in an underwriting position or making decisions, then they need to trust the information they're getting and maybe sometimes they want to understand the uncertainty. Sometimes if it's like hurricane activity, they want to adjust the frequency because they've got their own view on it or they calibrate it with their own loss data. Where do you see we are? I mean, we can work with this example. You might have another one. We haven't got self-driving cars yet because partly regulation, but I just don't think we'd also trust them to be completely independent. How do you manage that frontier of AI and going out to get information so that you can continue to not just have the kind of co-pilot model or hand over to, but I tend to think about it as a humble algorithm. So your AI has to know when it can go, I don't understand, doesn't hallucinate. Here's some really useful information. But this is what I didn't know. But I mean, we're nowhere close, unless you tell me we are, to being able to get 100% confidence of somebody's property information based on AI doing that, are we? There's still uncertainty in there. There's still gaps.
Absolutely. I mean, I love it when you bring up the autonomous car example because I think it's like the hardest. And it's the one with the highest stakes, get behind a machine going 70 miles an hour down. It feels like we insist on a level of accuracy that's, what is it, 6 Sigma or 9 nines or something like the level 5 level of autonomy in which that's just an incredible standard. I think we're not looking for that standard when we're trying to determine what type of roof I have and the quality of my roof or the age of the roof on our house, right? That requires a different level of rigor. But I still hear your point, which is what underwriters need is to spend less time bringing in 7 different data sources about a roof and understanding and more time tasking an agent to go out and summarize all the information it has about a roof and put error bars around it. So I think what you could ask an agent to do is not to give you an absolute answer, but to say, please go look at all 6 data sources I have on the roof type for Sarah's house and come up with a summary with some error bars. And I would argue that taking over the life of your entire business, if your error bars get tighter on the data quality and tighter on the data accuracy, you're going to make money. You're going to do better. So no one's asking for perfection. They're just asking for less error so you can make more decisions faster. That's, I think, the exercise, is to ask your agent to come back with an error bar that you say, wow, that's a better uncertainty, like level of uncertainty than I had before. I'm more confident in this decision, therefore I'm more comfortable doing this work. And here's the next piece that we have to sort of build into this, is some capacity to test whether or not this tighter band of uncertainty was more beneficial to you from an ROI perspective. And I think that can also be done. I think that's the agent in this case is not replacing an underwriter by any stretch. It's doing the work of an underwriter. So the underwriter looks at that uncertainty band and says, am I comfortable with that? Do I want to change it? Do I want to do something else? And then the decision is made. But I imagine an agent in the next year could absolutely go out and look within your own system and with the external world, say, give me a sense of what this roof is, its quality, its age, and then give me some uncertainty around it. And then the underwriter gets to work with that data.
Fantastic. That's your prediction. So we'll come back and see how we got on. So an agent will go out and be able to give you uncertainty around the property. Great. No, I think that's really clarifying. And I wonder if somebody in Bellwether now is sweating away thinking, crikey, Sarah's going to ask me to build that application now. But that was really helpful.
We've already done it. I've already brought it up with my team. I mean, problems that took us months to solve before. Now you can just say, well, tell me about all the buildings that were damaged in this hurricane.
Okay, but you can't cheat. You can't predict something you've got in your bottom drawer and you're going to pull out and say, this is what I did.
Well, I'm not saying we have. I'm just saying that even asking the question is just kind of mind-blowing. The idea that might be possible. I mean, I'm not saying Bellwether's done it. I'm saying Bellwether's talked about it, and we've all been kind of like, imagine that.
Perfect. You've got a vision. You're an entrepreneur. You've got a burning vision, got a big, hairy, audacious goal, and someone's going to go and figure it out. It's rather like we're going to put a man on the moon or maybe it should be a woman on the moon, the famous Kennedy quote, which everyone has to sort of rush behind. Hopefully you don't work your team quite as hard as NASA did to do that. So just before we wrap up,
tools better than slide rules. Isn't that amazing?
They put something on the moon a couple of weeks ago and it fell over. 60 years ago, we put 3 men, more than 3 men on the moon, and actually they all came back. A few sadly died at takeoff. But I mean, that is extraordinary if you think about technology, and we could do a whole different podcast on that.
It's so exciting. Some of these films about it, all the men in their white shirts and black ties and doing the math. Yeah, I love it. It's humbling as heck too.
We've covered a lot there. We went through the things you wanted to talk about. Is there anything we've missed off or anything we should talk about before we wrap up?
Bellwether is working on Severe Convective Storm. It's our next frontier, and we're excited to build in that direction and start talking about it with customers, I should say.
Brilliant. Well, definitely a big need there. And we didn't talk about your coming over to London a couple of weeks ago. I was going to ask you about your views of London versus elsewhere, but we'll save that for next time. But if someone now wants not just to remember about Bellwether, but wants to go and convince somebody else in their organization to invite you in, what do you want to leave them with about what they need to remember about Bellwether? Well,
if you had to bring something back to your boss or your team and say, we're going to try this new technology, you could say, I learned last week that Bellwether, in a head-to-head analysis, improved the loss ratio by 10% for a large player at Lloyd's running a wildfire analysis, testing Bellwether. That's a real number. It's real. It's exciting. So we should get a chance. So have folks call us. Let's run the numbers. Let's do a test with you.
10% loss ratio improvement using Bellwether. I don't think we should say anything else there. So just going to say thank you very much. Thank you for starting early in the day. Always a pleasure to talk to you. Thanks for your support, and looking forward to seeing you in person again, either here in London or back in New York.
Thanks, Matthew. It was wonderful.
Well, if you've made it this far, then I'm pretty sure you found that as interesting as I did. The Instech podcast comes out every Sunday morning, where we spotlight the latest news, leading voices, and freshest updates across insurance that you need to know about. If you would like to take part in these conversations, head to www.instech.co to find out how you can join our network and be a part of the insurance intelligence for the curious.